In this lesson, we'll be looking at how in active transport, cells use energy to move small molecules into and out of the cell. Molecules can't always move spontaneously and effortlessly in and out of cells. Sometimes their transport needs energy, in which case the process is called active transport. Such energy expenditures may be necessary if the molecules or ions to be moved are being against their concentration gradient. In all active transport, proteins embed in the membrane, and they act like motorized revolving doors, pushing molecules across cell membranes regardless of the concentration of those molecules on either side of them. So the two types of active transport are primary and secondary, and they differ only in the source of the fuel that keeps the revolving doors spinning. The process of digestion provides an example of primary active transport, the type of active transport that occurs when energy from ATP molecules is used to fuel the transport of their molecules. To help break down food into more digestible bits, the cells lining your stomach in a safe environment putting large numbers of H+ ions, also called protons, into the stomach contents against their concentration gradient. You can see the illustration of this image being shown. As a result, H+ ions are more numerous in the stomach contents than inside the cells lining the stomach. All of this H+ pumping increases your ability to digest the food, but comes at a great energy cost in the form of usage of the high-energy molecule ATP, because the protons would not normally flow into a region against their concentration gradient. We will explore ATP in the next unit. Many transport proteins use an indirect method of fueling their activities rather than using energy released directly from ATP. In the process of secondary active transport, the transport protein simultaneously moves one molecule against its concentration gradient while letting another flow down its concentration gradient. Although no ATP is used directly in this process, at some other time and in some other location, energy from ATP was used to pump one of the molecules involved in the secondary transport process against its concentrated gradient. The process is a bit like using energy to pump water up to the top of a high water tower. Later, the water can be allowed to run out of the tower over a water wheel, which can in turn power a process such as grinding wheat into flour. Our bodies frequently use the energy from one reaction that occurs spontaneously to fuel another reaction that requires energy.